That would be harder. All right, let's talk about functions and their graphs. In my happy bubble, you could all take those 12 words at the top of the paper and write me a beautiful paragraph because you understand what all those words mean. If you don't feel like you could write a paragraph with those words, then you really need to read the beginning of section 2.3. All those words are in boldface type, and you just need to make sure that you understand how to use them in a sentence, because I'll be using them in a sentence. All right, real quickly, here's basically what it says. A relation is just some association between two variables. They may or may not be numbers. It could be your name, comma, your eye color. But usually in algebra, our relations are numbers, and there's just some correspondence between them. There are no special rules that apply to a relation. However, there's a special kind of relation called a function, and there are special rules for functions. The rule for function, or the one rule for functions, is each x only corresponds to one y. Now think about this. If I said I have the relation which is your name, comma, your age. Each name can only correspond to one age in order to be a function. If I call out your name and say, how old are you? How many possible right answers are there to that question? There's only one. You're only one age right now. So that would be a function because each name is associated with only one age. But what if I define the relation in the other way and said my x's are going to be an age, my y's are going to be a name. I call out a name, an age, and if you are that age, raise your hand. If I call out 18, how many possible answers, how many possible people would raise their hand? One or more than one? More than one. So that would be more than one y belonging to one x. That's an example of something that's not a function. The definition of function is each x can only correspond to one y. Each question only has one answer. If you think of a function as being a machine that you build to do something, then for each x you put in, there's only one right answer that comes spitting out. If I said, what is the square root of 9? Those words actually imply both positive and negative square root. So if I said, what's the square root of 9? There's two answers to that, positive 3 and negative 3. So that wouldn't be a function. The independent variable is the x value, the one that you give me, and then the dependent variable is the y value. You put an independent variable into the machine, and it spits out the dependent variable. The y you get out depends on the x you put in. The domain is the set of all values for which the function is defined. All values that you can let x be that won't blow up the machine. The range is the set of all y values that can be obtained by the function. So anything that the box or the machine could spit out, that's in the range of that function. A one-to-one function has one additional requirement beyond just being a function. Being a function means that for each x there's only one y, but a one-to-one function has the additional requirement that each y only has one x as well. Now that's important when we talk about inverse of functions. I can build a squaring machine, and if I put in a 3, it spits out a 9. If I put in a negative 3, it spits out a 9. And that's a function because each number I put in only had one square. However, it's not a one-to-one function because two different x's had the same y, and that makes it hard to go backwards. Again, if I built a square rooting machine, and I didn't use the radical symbol, I just said, what is the square root of 9? There are two answers to that because squaring is not a one-to-one function. To see if something is a function, you can use the vertical line test. Some of you already knew that. You've already told me that. The vertical line test, if a function is, or if a relation is a function, then no matter where you draw a vertical line, it only touches the graph in one place. That means for each x, there's only one y. For this x, there's only that y. For this x, there's only that y. If there's a vertical line test to see if something's a function, we could also come up with a horizontal line test to see if a function is one-to-one. This parabola definitely is the graph of a function, but it's not a one-to-one function because here's a horizontal line that indicates one y value having two different x values, and that's against the definition of one-to-one. We talked about the vertical line test. A rational function is just, what does the word rational mean in basic math? A rational number, what is that? Any number that can be written as a fraction. Rational in math means fraction. Rational in psychology means same. Two different things. But a rational function can be written as the quotient of two functions, just some function f and some function g. That's a rational function, is the quotient of two functions. We're going to talk about those a lot. An algebraic function, a composite function, let me save that for just a minute. You may remember, but we'll do an example. A composite function is when you take one function and put it into another function to build a single function that does the job of two. It cuts out the middleman. We'll come back to that. An algebraic function is just any combination of adding, subtracting, multiplying, dividing terms with x's in them, but no logs, no e's, no trig functions. When you get those logs and e's and trig functions, then you get into transcendental functions. So algebraic functions just don't have trig and logs in them. Transcendental functions have trig and log in them. All right, refer to those pages if you need to, but let's do some work here. Work that's leading up to the kinds of things that you're going to see in calculus. Number one is what, or no, not number one, number 8 is what kind of function? It's a linear function. It's a first degree function. If I graphed it, it would be what shape? Just be a straight line. What we did in college algebra was find f of 4. This means plug 4 into the function. Find f of -2. Just means plug -2 in the function. In pre-calculus and calculus, we start dealing with doing ugly and uglier and uglier things to functions. But I want you to just think of this as a recipe. This is a recipe telling you what to do to this function. This is a recipe telling you what to do to that function. We're just going to follow the recipe. We're supposed to find f of x minus f of 1 divided by x minus 1 for that function. Now, this is just a recipe. What do I put in the place of f of x? Wow, that was unanimous. Awesome. That's f of x. What does the recipe say next? Subtract f of 1. And f of 1 just means put 1 in the place of the x. 3 times 1 minus 1. What's wrong with what I've written so far? Either I have to distribute that negative completely, or I have to keep this f of 1 in parentheses until I finish simplifying it. All right, that's a common mistake right there. I wanted you to watch out for it. Here's f of 1. So this is f of x minus f of 1 in the numerator. And what about this x minus 1? Do I put that into the function? It doesn't say it's f of x minus 1. It just says x minus 1. I've done exactly what the recipe said. F of x minus f of 1, all divided by x minus 1. I just want to simplify that as much as possible. I don't want to leave that as my answer. So simplifying this, 3 times 1 is 3, 3 minus 1 is 2. So this is 3x minus 1 minus 2 over x minus 1. And I have some like terms that I can combine. Is there anything else I can do, or is that it? Oh, I can factor a 3 out of the numerator, because then I can see that I have a common factor, and I know it's legal to cancel common factors, and that simplifies to just 3. Now, just a preview of calculus. We're not in calculus yet, but just a preview. That came out to be 3, and when I look back at this original function, it had a 3 in it. What's special about the 3 in this original function? What's it in the place of? It's the slope of the line. Wonder if that's just a coincidence. What if I had f of 7x plus 4? I wonder if I'd just come out with 7. Well, we don't have time to do it, but yes, you would just come out to 7. Because remember the little aside we had yesterday? We said algebra can be used to find the slope of a line, but when you have a curve, it doesn't make sense to talk about the slope of a curve unless you're talking about at a particular point. Well, calculus, there's 2 big things in calculus, the derivative and the integral. We'll spend most of the semester talking about the derivative. At the very end, we'll talk about the integral. But the derivative gives us the slope. So it makes sense that this, which you didn't realize, but it's pretty darn close to the definition of the derivative, it gave us the slope. And whatever this function is, if we find the derivative, whatever that means, at this point, it'll give us the slope of that line. So all I want you to have in your head right now is slope and derivative have a lot to do with each other. The derivative can be used to find the slope at a point, so it's not surprising that that gave us the slope of that line. All right, second example. Not a linear function. It's a what kind of function? It's a quadratic function, and this recipe looks just a little bit different than that recipe. This is called the difference quotient. You may have seen it in college algebra. It's not calculus until we add something else to it. At this point, it's just algebra. And f of x plus h tells me to do what? Put x plus h in the place of both x's. That's what f of anything means. If you say find f of cow, I'll put cow in the place of both x's. F of x plus h is x plus h squared minus x plus h. I'm going to put it in brackets, even though I don't really need them, to say all of that is f of x plus h. You need just a jiffy to write it down, and then you need a jiffy to let your eyes adjust to it so that you can see that this is just x plus h put right here and x plus h put right there. I should have accidentally left out those parentheses to see if you caught it. So automatic to me to use parentheses. I didn't think to do that, but it's important that I have that x plus h in parentheses until I distribute the negative. All right, first part of the recipe done. Second part of the recipe says subtract f of x. What's f of x?
Squared minus x.
X squared minus x. What's wrong with what I just wrote? I need to subtract the whole thing, not just the x squared. That's my f of x. So far I have f of x plus h right here, and I have f of x here, and then the denominator is just h. Does that mean put h in place of x? No, it didn't say f of h, it just said h. And then it's just a matter of cleaning that up. Now, when I say that by the time you get to calculus, you need to be able to do a little bit in your head, I don't want you to have to write x plus h times x plus h and FOIL it out. It's going to take you a lot of paper to do that. I want you to be able to FOIL x plus h times x plus h in your head. That's x squared plus 2xh plus h squared. Then distribute that first negative, minus x minus h. And then distribute that negative, minus x squared plus x. Double check it. X squared plus 2xh plus h squared minus x squared plus x, all divided by h. Oops, sorry. There you go. And then clean that up as much as possible. The lovely thing about the difference quotient is usually in the process of cleaning it up, a whole lot of stuff goes away. This x squared minus x squared is 0. This negative x plus x is 0. And that's the only like terms I have. But what do all the remaining terms in the numerator have in common? They all have an h. So what can I do to simplify this fraction further? Factor out an h. When I factor out an h, I'd be left with 2x plus h minus 1. Gotta have that minus 1. Oh, shoot. And then, sure enough, my h's cancel. And I'm left with 2x plus h minus 1. Now again, we haven't done any calculus yet, but we're right on the cusp of it. And I'm just kind of thinking ahead. Why did this, whatever's special about it, I don't know yet, but why did this give me just a number, 3, but this, whatever's special about it, didn't just give me a number, it gave me an algebraic expression. Now, if you can answer that, I will be tickled to death. If you can't answer it, I'm not disappointed in you, because that's really thinking way ahead. But why is this a constant and that's not a constant? Because this is a linear function, and the slope of a linear function is a constant. This is not a linear function. Actually, it's a parabola. It's a concave up parabola. And at some points on that parabola, the slope will be positive. At some points on that parabola, the slope will be negative. What's the slope right here? 0. All right, so the derivative, when we get to it, whatever that means, the derivative of a linear function is going to be a constant because the slope is constant. The derivative, whatever that means, of a nonlinear function is not going to be a constant. Now, just a preview to what's coming next week, we have that 2x, we have on blah, 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 equals 2x plus h minus 1. The only thing that we would have to add to that in order for it to be calculus is this notation right here.
Yay.
Yay! This is what we're going to talk about next week, that limit notation. The limit as h goes to 0 means as h gets smaller and smaller and smaller and just infinitely small, what would be left of this thing if the h got so close to 0 that it practically went away? 2x minus 1. Here's what we're going to find out in chapter 3. 2x minus 1 is the derivative of that function. All right. Just like you to be thinking ahead, although if you don't totally get it yet, it's okay. Number 30. That thinking ahead is not to make you nauseous. That's not the point. What do you call a function that's defined to be two different things for different parts of its domain? What's the name of that kind of function? Piecewise function. The first time I heard a professor say piecewise function, I thought he was making it up. My Cal 1 professor looked like a truck driver. He always had a pack of cigarettes rolled up in his plaid button-down shirt. And then he started talking about piecewise functions, and I thought he was just smoking crack. But no, it is. It's a piecewise function. It's called piecewise because it's defined to be two different things for two different parts of its domain. For all the x's less than or equal to 1, the function's defined to be x squared plus 2. For all the values of x that are greater than 1, this function's defined to be 2x squared plus 2. So this part of the function is a parabola. This part of a function is a parabola. The parabola pieces may or may not cross anywhere. I don't know. That's not what I'm trying to figure out right now. The C part of this problem says find f of 1. How do I find f of 1? The top function is, or the top piece is the piece that's defined when x equals exactly 1. So to find f of 1, I plug 1 into the first part of that function. F of 1 would be 1 squared plus 2, which is 3. If I ask you to find f of 7, which piece of the function would you use? Yeah, the second half of the function is for all the x's greater than 1. 7 certainly greater than 1, so you would plug 7 into the second part of the function. What about f of s squared plus 2? I don't know what s is, so I don't know if s squared plus 2 is greater than 1 or less than 1. I don't know which piece to plug it into. No. I don't have to. Why does it have to be greater than 1? Beautiful. The very smallest thing s squared can be is 0. And when you add 2 to it, you can't possibly get anything less than 1. So even though you don't know what s is, even though you don't know what s squared plus 2 is, you know it's got to be bigger than 1. So you put s squared plus 2 in the place of the x in the second piece of that function. Now, on the test, I would want you to simplify that. Just because I know you wouldn't have a problem with that, we're going to go on.
Wouldn't that s squared plus 2b squared?
Gosh darn it, I left out a square. Absolutely. I'm putting duck in the place of x, and I forgot to square it. All right, thank you very much. In calculus, we're going to have ducks that are so ugly, we just call them ugly. This is going to be 2 ugly plus 2 with s squared plus 2 in the place of ugly.
I don't think it appreciates that.
I'm sorry. It needs to get tough there. Not being offended. All right, number 12, 16, and 28 say find the domain in the range of the following function. Domain means what? What you can let x be that doesn't blow up the function. And range means any y value that could possibly come out of that function. So number 12, what is the domain of the function x squared minus 5? Is there anything that'll blow up that function? You can square and subtract 5 for any number in the whole wide world. So that domain is negative infinity to infinity if I write it in interval notation.
Is that how you?
Yes, I'm almost positive that's how it'll be written in the back of the book. Let me know if I'm wrong about that, but I think they'll use interval notation. What about the range? What kind of y values can be obtained by squaring numbers and then subtracting 5? Anything greater than 5? Right, anything greater than negative 5? What's the very smallest thing you can get from x squared? 0. And if you take that very smallest thing and subtract 5 from it, then negative 5 is the very smallest thing you can get. Or if you think about this graph, it's a parabola which has been shifted how? Down 5, so the lowest y value when it's going to be negative 5, and then it's going to go forever up. So how would you write the range in interval notation? Perfect. The lowest point on that graph is going to be negative 5. It's actually going to hit negative 5. The bracket means including. And then it's going to go forever up to infinity. To get the range, it's usually easiest for me to look at the graph or imagine what the graph would look like. I can think of that graph being from negative 5 up, and that's how I get the range. The number 16, h of x equals negative square root of x plus 3. What can you let x be without blowing up that function? It has to be, you can take the square root of negative 3 plus 3. Negative 3 is okay, but nothing less than negative 3 would be okay. I've got to have more than negative 3 or negative 3 itself. So that domain is from negative 3 to infinity, including negative 3, because that would just give me square root of 0, which is not a problem. What about the range of that function? What does that graph look like? Square root of x plus 3. Half a sideways parabola, and because of that negative coefficient, which half of the sideways parabola is it? It's the bottom half of a sideways parabola. It's the bottom half of a sideways parabola that's been shifted 3 to the left. 1, 2, 3, bottom half of a sideways parabola. How low is that sideways parabola going to go in terms of the y values? It's going to keep going down forever. What's the highest point on that half a sideways parabola? 0. So how do you write that range in interval notation? You knew that interval notation has to be from lowest to highest. Here we go. Lowest to highest. It doesn't make sense to write 0 to negative infinity because that's not in order, lowest to highest, and interval notation always is. Number 28. What can you let x be? Anything that'll blow up that function? 2, because 2 would give me 2 squared is 4, 4 minus 4 is 0, absolute value of 0, 2 would give me 0 in the denominator. Is there anything else? Can't let x be negative 2 for the same reason. So if you write that in interval notation, you have to go negative infinity up to negative 2, not including negative 2. Negative 2 to positive 2, not including either one. 2 to infinity, not including the 2. That's just a pain in the patootie. I know you could, but I'm just going to write x cannot be plus or minus 2. That gets the point across without having to write all that other stuff. What about the range of that function? Yesterday, no, I think it was first day of class, I almost had on your handout, absolute value of x is always a V-shaped graph, or a graph with absolute value is always V-shaped. And then I caught myself and added the word linear. Absolute value of a linear function is always V-shaped. This is not a linear expression. It's a quadratic expression, and if I graphed it, it wouldn't be a V. I can either graph it, kind of have to make a table and think real hard about it, or I could graph it on my calculator. But tell me what you can figure out about the range. What is something that I could not possibly get from that fraction? I couldn't get 0. I can't get 0 from any fraction unless it has 0 in the numerator. This doesn't have 0 in the numerator, so I know that 0 is not in the range. What else couldn't be in the range? What can you not get from 1 over the absolute value of something? You can't get a negative out of that, because this absolute value is never going to be negative. And 1 divided by something that's not negative can't be negative. We know we can't get 0. I know I can't get negatives. Is there anything else I can't get? Let's see. Anything higher than 1? That's a good idea. I see why you're saying that. If you're chopping 1 cookie into some pieces, nobody can get more than a whole cookie. That's awesome. Let me think though. Let me say, what if I let x be 1 here? If I let x be 1, that would be 1 over what? It'd be 1/3. What if I let x be 5? Be 1 over 21. So far so good. Let's check out fractions to just be sure. What if I let x be a half? A half squared is a fourth. A fourth minus 4. That's 1/4 minus is negative 15/4. I'm going to take the absolute value, it's positive 15/4. And then when I flip it, what? I'm not sure I said that right. Let me try again. 1/4 squared is 1/16. 1/16 minus 16/16 is negative 15/16. Positive 15/16. Flip it 16 over 5. I can get something bigger than 1 if what I have in the absolute value is a fraction smaller than 1. When I flip it, it'll be a fraction bigger than 1. So that was a great thing to consider. It turns out that I can get numbers bigger than 1. Is there anything else we want to see if it's possible to get? Could we get you said we couldn't get 0, we couldn't get negatives. I like your idea. Let's just graph this and see. If you have a graphing calculator with you, go ahead and graph that. And make sure you know where absolute value is on your calculator. Ooh, we got to speed up. We're about to get behind here. Here's my graphing calculator. 1 divided by absolute value is under your math menu, which is right under your alpha key. I think. I'm going to have to look, but I think this is where it is. Math, and then curse over to 1 to number, and it's number 1, ABS. Absolute value of x squared, what was it, minus 4? Yeah. All right, so that's what it looks like on my calculator. 1 over the absolute value of x squared minus 4. Whoa, that's kind of cute.
Well, it's like a heartbeat.
It does. That somebody dies on either end of it.
With me.
So
I'm the one that goes through
I can get, oh, but what about the highest peak of that graph? I may not be able to get anything bigger than that peak right there. Let me zoom in on it a little bit. Let's let those y's be, I'm going to do my, oh, that's not what I meant. I'm going to make my x's just go from -5 to 5, counting by ones. And I'm going to let my y's be from, well, now that I know it's not going to go below the x-axis, I'm just going to do 0 to, whoops, 0 to, I can see the graph changing right here. If I leave it 0 to 10, I can see, oh, it is going to get higher than -4. If I go all the way 0 to 100, counting by tens, now I'm thinking this is something I should have graphed in my office before I came to class. Go down, what are you calling the next one? Oh, that changes the resolution. That's not.
I mean, like,
Are you
just
trying to
like
get the graph
to set that in.
I'm just trying to see how high the graph goes. And yeah, let's do that. Zoom and fit is number what?
0. Like, just go away.
Zoom stat, zoom fit. I am darn tempted to say that this range is from 0 to infinity because it looks like that on my graph. It's going to look like that peak goes up. But I tell you what I'm going to do. I'm going to highlight that. Ooh, what did I do wrong with what I just wrote? I put a bracket on the 0 and we already said we can't get 0. So I'm going to put that as my answer, but because I've highlighted it, I'm going to think about it when I get back to my office and get back with you tomorrow. I don't feel totally 100% confident in that answer, but I don't want to spend any more time on it in class right now. Dang it, we're not even through with the front page. Holy cow. We can do it. The next, yes. I used to teach calculus 3 days a week, and so the classes were just a little bit longer, and I'm going to have to learn how to squeeze it into 55 minutes and hush. I'm going to work on that. The next problem, say determine whether y is a function of x. That means use the what? If you're looking at a graph. Use the vertical line test. Does number 44 pass the vertical line test?
Yes.
Yes, no matter where you put a vertical line, it only touches the graph in no more than one place. So yes, it's a function. What about 46? Definitely a circle never passes a vertical line test. It's not a function. But how do you tell on 49 and 50 when you're not looking at the graph?
49 looks like a circle.
Yeah.
Say it again.
49 is kind of similar to a circle, but it has both the y and the x are squared.
You may not remember this from college algebra, and if you don't, it's okay. But if I subtracted y squared from both sides and added 1 to both sides, I'd have x squared minus y squared is 1. You happen to remember which conic section has both variables squared, but one of them has a negative coefficient? Starts with an H. It's a hyperbola. You don't have to know that. You can remember any equation with a y squared in it, it's not going to be a function, because if you solve that for y, what would happen on the left-hand side? Y equals plus or minus. That plus or minus means you're going to have two different, or you're going to have one x that you can get two different y's from. So without having to go back and dig up hyperbolas, you can just make yourself a note: if it has a y squared, it's not a function. Because if you solve for y, you'd have plus or minus, and that means one x could give you two different y's. So I'm just going to say no because of the y squared. What about number 50? You think that's a function?
That's the one that was on the phone.
Oh yeah, you've seen it before?
Yeah, I remember distinctly. I had a nightmare about it.
I'm sorry. Do you think it's a function? I know it wouldn't be if it had a y square in it. It doesn't have a y square in it. Could I solve that for y?
Good.
I can get the terms with a y on one side, the terms without a y on the other side. Then I could factor out a y and divide by what's left. Eventually I'd have y equals blah, 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 and each different x would give me a different y. So that is a function. I'm not sure exactly what its graph would look like, but it's definitely a function. You could solve it for y and have y in terms of x. And for any x you put in, there would be only one right answer for what y is. All right, I'm glad we got to this, even if it's quickly, because at the top of the page, I asked you to hold on when I got to the term composite function. Let me give you the official definition of composite function, page 25-ish in your book. And then let's talk about how to make that official version a little bit more understandable. Let f and g be functions. Another function can be formed, and the name of this other function is literally read f circle g. You just read that circle, circle. F circle g of x. Alternate notation is f of g of x. That means you take g of x, whatever ugly it is, and put it into f. You're taking one function and putting it into another function to develop a function that does the job of both, and the middleman gets fired. That's called the composite function of f with g. The domain of f circle g is the set of all x's in the domain of g. That means you can't have anything in the domain of the composite function that you could not have put originally in the function g, such that g of x is in the domain of f. That's just hard. That's hard for my brain. All right? Let's think about this problem a minute and what all those words mean. F of x is the reciprocal function. G of x is a add to and take the square root function. Those are both functions. For any x I put in, I only get one y out of each one of them. I have to hire 3 guys. By guys, I mean guys or girls. 3 guys to do this job. I have to have a guy that takes a number, puts it into the reciprocal function, and the reciprocal function flips that number. I have to have a guy in the middle that catches that answer and puts it into the next machine, and then I have to have a third guy that catches the answer that comes out of the second machine. I don't have that much money in payroll. I want to build one function that will do the job of both, and then I'll only have to have a guy put the number into the composite and a number that a guy that catches the answer, no guy in the middle. All right, so this says find f circle g of x. And that means take g of x, whatever it is, and put it into the function f. This notation actually makes more sense. Takes g of x, whatever it is, and put it into f. The one that's closest to the x in the circle notation, that's the one you're putting into the other. So take g of x. G of x is square root of x plus 2. Take square root of x plus 2 and put it into the function f. What happens to square root of x plus 2 when I put it into this function f? What will I get? Instead of 1 over x, I have 1 over square root of x plus 2. Now, if I put on my three-man system, if I put a, let's say I put a 1/7 into the function f, what would come out the first function? I have 7. I have a guy that catches that 7 and puts it into the second function. What comes out of the second function? If I put a 7 in. 7 plus 2 is 9, or 9 is 3. So I put in a 1/7, I got out of 3. This should give me the same answer. It's less easy to do in my head though. Ooh. Why that's easy to do in my head? Oh, because I see what I did. I just messed up. This, I should have taken whatever number, I should have taken like, put 2 in place of x. And what would g of x spit out? A 2, and then put 2 in place of that x, and this would spit out a half. If I put 2 here, I should get the same 1/2 without having the guy in the middle. I'm sorry I messed that up. That's f of g of x. The domain would be anything that you could put into g of x. What can you put into g of x? Anything bigger than or equal to -2. I could put -2 into g of x. But what can I put into g of x that whatever I get out, I could also put into this? That's so hard to say. What could I put here that I could not put here? -2. I could have used -2 here, but I can't use -2 here. So the domain of that function is just anything bigger than -2, but not equal to -2. And then G circle F of X means take F of X, whatever it is, and put it into G. Well, what is F of X? 1 over X. So that's what I need to put in place of X in the function G. Instead of square root of X plus 2, I have square root of 1 over X plus 2. If you happen to have one like this in the homework, let me just say I'm pretty darn sure they're going to go ahead and get a common denominator and add those. Square root of 1 plus 2x. That's probably how the answer in the back of the book is written. But I'm going to put 4 there because on the test, you've done all the hard work, and I give you credit for either that or that. I actually did sit in my office and squint and think hard and figure out the domain of that function. It took me 10 minutes to do it in my office, and we don't have 10 minutes. So let me just say in the homework, if you find the composite functions, you can stop there. You don't have to find their domain. Let me tell you real quickly what we didn't get to, and then the homework. The thing we didn't get to that I think you'd be pretty much okay with is graphs of polynomial functions. you know that if the exponent's even, either both ends go up or both ends go down, depending on the leading coefficient, whether it's positive or negative. Odd degree function goes down on one end, up on the other. Which end goes up, which end goes down, depends on the leading coefficient. You should know about shifting of polynomial functions and how to graph a basic polynomial function. And maybe you even remember how to graph a rational function. But I think you'll be okay on this homework even without us getting to that back page of the notes. If you have any problems, email me. I will be happy to help.
We leave out the domain.
Don't worry about domain of a composite function. Find the composite function, just don't worry about the domain.
Did you have the answer to G of F or
The domain,
G circle F 70?
yes, the domain actually comes out to be Ooh, awesome. I would have to explain in order for that to be positive, so you can't take the square root of a negative. Either both of those have to be positive or both of them have to be negative. And then I have to make a little number line and here next time. Good job.
But these are things that went over.
I'll have to think about that.
It's like then you just gotta think like what would make it less than 0.
And what would make it, you'd have to think what would make it bigger than -2, as long as that's.
I mean, what would make the whole radical less than? Then it would be imaginary if it took the square root of the negative.
I think it's probably one of those flip a coin. Some people think easier about it this way, and some people think easier about it this way.
All right.
But yeah, cool. I'm glad you got it. Hey, sir, how are you?
Okay, I guess.
Good.
I just wanted to ask you on the new economy absent.
I forgot to call roll this morning. Stone will be asking me if everybody was here. Gosh darn it. I would trust you. The only reason I take attendance is because I have to report the high school students' attendance across the road. It really doesn't count as any part of your grade. But thank you for checking with me. Hello, ladies.